I work with Tenable, as it was mentioned, and Tenable is a cyber exposure company. We provide customers with the information, and we help them understanding the cyber exposure to the risks and vulnerabilities that there are. And actually we deal a lot with a very sensitive data, because vulnerability, the data is extremely sensitive. It points to the weak points, basically. And I work as a data scientist, and I've been working with in the cyber security area for about 10 years in various ways, and all that time I have been using Python. And today I will, well, first I will explain why we want to anonymize data, okay? And then for the purpose of the talk, we will actually, I hope, well, I'm not sure if the demo will work, but we will try to generate some synthetic data using a fake module that was mentioned by Anna as well previously. And then I will show how Faker and mimesis modules can be used for anonymizing data. And finally, yeah, I talk about some limitations and summary on this. So first of all, why do we need to anonymize data? Right. So a lot of times when we do analysis on the data, we have personally identifiable information there, right? And we really need to protect this data, right? We need to protect this data to protect our customers, also for also to comply with the laws, and data anonymization is one of the methods along other methods. So we can encrypt the data. We can control access through authentication and authorization. But when those measures fail, and they most likely will fail, then we still have to protect the data, even if the third party gets access to it, and that's where data anonymization comes in, right? Because then we remove all the PII information and replace it with some other information there. So a quick example of what is PII, so we know what we are talking about. So PII would be like name. It would be an email address. It would be a postal address, or in case of if we talk about the information about hosts and machines, things like IP address, host name, and MAC address, that's quite sensitive. What is not really sensitive is like a rough location, like for example country. Let's say information about what items I bought online. I don't really care if someone knows that, oh, I bought a shirt for like 35 euro. And in case of other information, things like, yeah, what amount of RAM I have there, operating system, and yeah, that's not really that sensitive. So we basically want to protect all the information in the orange area there. So when we anonymize the data for analysis, we can do this actually in two places. So the first place would be when we actually get the raw data and we want to store it for further analysis, right? So that's the first first place where we want to do that. And in this place, we want to preserve integrity and uniqueness of the data and the distribution, and also some semantic relationship. If there is a name, we still want to know that it is a name. It's just we are not interested that, oh, is it John or is it Sean or something, but we still want to know it is a name. So we know that. But then, even if we do that, it is possible to derive some information by correlating the data. So after analysis, before publishing, we would still want to further anonymize the data, and that's where we can introduce noise, but then we will lose information that we would want to use for analysis. So we will focus in this talk. We will focus mainly on the tokenization, which is the part where we transform the data from the raw data to the analyzed data set. And actually, we have three methods possible there, and so wait, okay, it's got a bit. Yeah, so but basically we have methods like removal, where we can remove completely information, but then yeah, if we remove information, we cannot analyze it anymore. So we have to be sure that if we remove information, then then this is information that we really can live without. And then the second option is masking, and yeah, we can, on this example, we can mask it with some either some string, or we could use, let's say, SHA-256 of a value, but then that becomes tricky because, for example, if you want to anonymize, let's say, IP addresses, there is only like a 4 billion values that there are, so it's quite easy to generate a lookup table and then do reverse lookups. So with masking, it is important to make sure that that we introduce a salt or some things like this. And then the third option is a tokenization, that is basically a substitution of the original value with a synthetic value there. And then the rest, the differential privacy and K anonymity, those are methods that are more complex, and they introduce noise. So so we will not talk about those here at this talk. And the modules that are available that we can use for anonymization are mimesis and faker, and also there is a anonymized module and a scrub-adobe. We will focus mainly on mimesis and faker because they provide most features. An anonymized module provides only masking and removal, and a scrub-adobe is quite interesting because it works on unstructured text, and it can analyze the text and find actually, okay, there is name in there, but then the tokenization is very simple. It just says, okay, this is name 1, name 2, and so on. So it doesn't really give the idea that, okay, this data actually looks quite real after anonymization. So yeah, how would we get that? So all those modules are available through pip. So we can just simply do pip install faker mimesis, and works. It gets installed. So now, what we can do actually first, we can see how we can generate synthetic data. And actually, in the previous talk, Anna was talking about using Faker as well for with Django for testing, and that's a great method to get data for testing. And here we can see that we want to generate in this example, let's say a set of responses from the from a web server where it logs the users, their agents of the browsers that are visiting the page. Okay, so we can generate a username and an email and the MAC address and the user agent, and in this case we want this data to look like a real data. So so for the name we want to make it look like a name, and for the email we want email to look like an email, and the MAC address to look like a MAC address, right? So so this is achieved through providers, and both mimesis and Faker modules, they have providers for a different type of data. For example, like addresses, transport, file paths, internet-related values. Now, actually, see if I can do the. No, I'm afraid the demo would not work. So, so I just go through this. So now, how can we use a mimesis and Faker for anonymizing data? Okay. So the trick here is to create a mapping dictionary, right, between the original data and the anonymized data. Now, the one thing that actually I forgot to mention earlier, that when we anonymize the data, we basically want a one-way transform. So we want to destroy the data in such a way that we cannot recover the original value, but at the same time we still want to know that, let's say, a host A is different than host B, right? So so the way we achieve it here is that that during anonymization we construct a default dictionary here with a values where we have a mapping from the original value to a anonymized value, and the anonymized value is generated by Faker or mimesis. And then once we are done, we destroy that dictionary. And here we can see example where we define so this is this example actually with mimesis and Faker, where we can define what kind of data we want to anonymize and how using providers. So providers give us back like by using providers we preserve the characteristics of the data, and then when we run anonymization, well, we basically define first in the anonymize row function what fields we want to anonymize, and in this case we want to anonymize the username, the email address, and the MAC, but we don't anonymize the user agent because that's what we want to analyze, and that's not really considered a personal information. And then in the next function, anonymize file, we basically go row by row and then substitute the original value with a synthetic value, and that's how talk organizing works. And yeah, so if we look now at some sample data And so on the left-hand side, we have the data before anonymization, and on the right-hand side, we have the data after anonymization. So we can see that the email addresses have been changed, the MAC addresses have been changed, and the username have been changed. But they still look like email addresses, they still look like MAC addresses, and they still look like usernames. So we preserve all the information we want to preserve, and yet we destroy all the information that would allow to identify the persons or machines. Now the limitations of this method is that actually we can anonymize the data in one go, and it works very well. But because we destroy the mapping between the original values and the anonymized values, during the second run, we would get different anonymized values for the same original values. So it works fine if we anonymize the data in one go, but we have to be cautious that between the runs we lose some information. So we might try to. Well, so we actually tried to find a solution to that, and we thought, okay, if we see the random number generator, we would get the same mapping all the time. It didn't really work because it really did depend on the order in which the data appears. So probably the next thing we try would be defining a custom provider, because with both the mimesis and faker, we can define a custom provider there. And that are actually pretty. I think I went through this pretty fast, but I might actually I might try to do the demo on that. Let me see if I can do this. Okay, so I might actually try to do the quick demo. Not this one. Okay, so this is our code for generating a synthetic data, and I try to run it now. So we can see. Okay, so we should now have actually two files, because if I go back here. So we generate data. Two entries for a data1 file, and then two entries for the data2 file. So now, if we look what is in data1, okay, so we can see that we have our synthetic data with the emails and MAC and user agents, right? For the data two, what we have similar data, and also what we did here, we can see that actually the first entry is the same as the fourth entry, because I copied it there, and then we try to anonymize it with a faker. So actually the code, so this is the code that we were looking at previously, and so we have our mapping defined at the top, and then we have functions to anonymize the raw of data and the file. So now if I run it. So we give data1 JSON, and we do data1, let's call it F for faker. Okay, and if you now show this, so we should be able to see now that the in the first entry, the user agent is the same as it was, but the MAC address is different and the email address is different, and likewise for the second row. And now if we try to run it again, the mapping would be generated again. So now if we do this on the data2, we can actually show the limitation of this method, where if we show the data2, we can see that actually the fourth entry, even that in the original data here, this entry was the same as the entry at the top, but in the anonymized data, the email addresses between the first entry and the fourth entry are different. So we actually lost a bit of mapping there. Okay, so go. Okay, so I think I can wrap it now. So we have so we have to anonymize the data to protect the sensitive information, but at the same time, for analysis, we want to preserve the integrity, distribution, and the semantic of the data, so we can do all the aggregates and analysis that we want. Now, two modules are pretty nice to use it, so there is mimesis and faker, and mimesis works with Python 3 only. So if someone still runs any code on Python 2, then faker is the way to go. One thing that I didn't mention is actually that both modules supports a lot of locales, so they allow to anonymize data in different languages. So let's say if we have data in German or in French, and we want to keep this information, and we want to let's say have still like German and French names, we can use appropriate locale, and both of them give us many providers. So so there are different types of data, a lot of different types of data that we can anonymize, and mimesis has a slightly better performance than faker, so that's what would differentiate those two. And that's all. Would you have any questions?
Are there any questions for Bartek? Are these all open source packages available? Are they on GitHub? The mimesis and faker?
Yeah. Both are available on GitHub, and both are available through pip.
Okay. Sorry.
Hello. When you use like fuzzy scores and stuffs to create a subset of the data, and still the data is like really sensitive, what can be the right approach for anonymizing that? So I have a subset of data. I have a data, but I have like a fuzzy score, something which runs on it, and but I still need it to be masked, or stuff like that. So when you use like faker, it creates new sets of email IDs. Then I cannot run my fuzzy scores on that because it will be different. I don't really get a correct score, so I can create my correct subset of data, if you get what I'm saying.
I'm not sure.
Sorry. One of the problems which I'm actually facing right now of Pycon, the data is like really sensitive, but you still need to run some fuzzy scores on it, and you can't really create a subset of data to work on it, because the moment you use like Faker or any anonymizing tool on it, my data is entirely changed. The context changes, so your data analysis doesn't really work as it's supposed to be with the original data.
Right. So yeah, I think I'm not sure exactly what analysis you want to do on the data, but this method is supposed to preserve the uniqueness of the data. So if you have a user A and a user B, after anonymization, you would still be able to differentiate them. That okay, this is a user's A data and this is a user B data. So for any aggregations, it would work this way, like you can tokenize data and you know, like in this context here, like we would want to know that okay, the email address is still an email address. We are not interested that okay, there's a email address of let's say Bartek, right? That is my email address. We want to know that okay, it's a email address of a user X, right? And so this was why we can do all the aggregates on the email address.
Okay, thank you.
Anyone else with a question?
Are there any libraries for image?
Yes, so there are actually providers that would give you like a random image. So you basically, if you have an image, you replace the image with a different one. So basically, a token is your brand new image. The problem with like encryption and anonymizing images is that if you go to the pixel level, you might still reveal the content of the image. Like there is a known example actually of a Linux penguin that is encrypted with encryption algorithm. I think it's AES 1 to 8, and it is encrypted, but you still can see that okay, it's a penguin on an image. So you would rather want to replace the whole image in this case.
Yeah, and are there any way to anonymize data more? For example, if I want to count how many of the email addresses are on gmail.com, so and I want to remove only that part, but leave the gmail.com out.
Yeah. Yeah, so you can create actually your own provider, and then you can parse the email addresses and anonymize separately the users, their names and domains. So then same domain would be always would have the same value, the same anonymized value. So then you can count those.
Anyone else?
So is that there any tools you can use if your data is bigger than your memory to ensure that the anonymized data will still be created the same for the same input.
Yes. So this actually I found that probably would not work. But you can revert to masking. It's not perfect, but if you use algorithms like HMAC, it gives some security there. Yeah, just don't simply hash with SHA-256 or MD5 because it's quite simple. But something like HMAC should work.
Okay, one more quick one, I think, and then we'll wrap up.
Hi, thanks for the talk. I was wondering whether you knew or could recommend any tool to identify PII in free text. I don't know if there is such a thing, and maybe it's
right. I'm afraid I don't know really.
Okay.
Yeah.
As in, you know, oh, this looks like a phone number. Maybe you want to anonymize that. That kind of stuff.
Yeah.
I don't know.
Yeah, it's a good question. Actually, it's really good question, and I guess one could make the some regular expressions and try to detect that, but I'm not aware actually of an existing tools. So.
Okay, I think we'll leave it there, and thank Bartek again for his talk.
Okay.